Hey everyone. So today we will be covering Snowflake. So this will be a two-part session. In the first session, we will be covering a lot of things about Snowflake, like what Snowflake is, what is its architecture, right? How many additions are there, um, how Snowflake stores data, how UI looks like, um, and uh, and then some basic queries how to run them, right? And some basic concepts about Snowflake. The second session will be all about practicals, how to run queries in Snowflake, what are different views, stages and all, right? So let's talk about Snowflake first, and maybe we'll talk about Snowflake practical later. So when we talk about Snowflake, right, Snowflake is a cloud computing based data warehouse company based in Bozeman, Montana. It was founded in July 2012 and was publicly launched in October 2014. Snowflake offers a cloud-based data storage and analytics services, generally termed as data warehouse as a service. It allows user to store and analyze data using cloud-based hardware and software. Snowflake runs on S3 since 2014, on Microsoft Azure since 2018, on GCP since 2019. So all in all, in very simple terms, what Snowflake is doing, Snowflake is providing us data warehousing services on cloud, right? And when we talk about cloud, it means all the infrastructure what is needed to implement a data warehouse is Snowflake is taking care of it. But Snowflake is software as a service platform. It means it will manage all the infrastructure what is needed. It will manage all the software installation. You just need to worry about your data analysis and your data marts and creating a data warehouse, right? The modeling, data modeling and data analysis. Before we jump further, let's talk about what exactly a difference between data warehouse and data lake and database. So let's first talk about what exactly is a data warehouse and how it is different from a database. So when we talk about database, right, it is mainly used for OLTP application. It means it is used to record um, transactional data for you. And when we talk about data warehouse, it is mainly used for OLAP services. It means online analytical, purposes, right? Online analytical processing. When we talk about database, data is available in real time, and in for the data warehouse, data must be refreshing when needed, right? So these are few major differences. Uh, One more important difference between database and data warehouse is it stores detailed data, and data warehouse stores summarized data. Okay, in very simple terms, data warehouse is storing data from various different sources, um, and database is usually storing data from one particular source, right? Let's talk about, for example, um, when we talk about Amazon, right, there can be multiple databases exist, but there will be only one or two data warehouses in which uh, you know Amazon business people might be asking reports like, okay, what are the sales in North America for mobile phones in quarter 1 of 2022? So to do this, right, you need to join different databases, different tables, and do this query and send that report to them. Ideally, Amazon is a big company, right? And it when we talk about quarter 1 2022 mobile phones, right? North America. So basically, see, this is we are talking about a huge amount of data here. If we do this query onto database, it might take a lot of time, might take a lot of computing power, and it might impact the transactional activity what is going on database. So what people do, people move this data of different schemas or uh, different type of data to data warehouse on some particular time, on some particular schedule time, and then they will do all the analytical queries like this onto data warehouse. Okay, and that's what. data warehouse will have separate set of resources, so it won't impact database activities. Okay, now let's talk about how data warehouse is different from data lake. So when we talk about data warehouse, data data warehouse is nothing but uh, RDBMS behind the scene. So it means it will need data to be structured and to be processed, right? Data lake can store any type of data, structured, semi-structured, unstructured, raw. You can store anytime. Data lake is mainly used to dump the data, right? When we talk about data lake, you do not need to know the structure of the data before you dump it. You can give structure to it when you are reading it. That's why data lake is called schema on read. For example, in a very very simple terms, you have one file which has 4 columns. You do not need to know how many columns are there when you are writing it. When you are reading it, you will define some schema over that file and you can read that file. But in case of data warehouse, you need to know the schema before you writing it, because obviously here you will create the tables first, right? And then you'll load the data. um, in terms of costing, data warehouse is expensive for large data volumes. Data lake is designed for low cost storage. Data warehouse obviously is a very old technology. Oracle, Teradata are providing these services for very long, so it's very mature. Data lake is still maturing, right? When we talk about data warehouse, it is majorly meant for business professionals who need analytical uh, services, for example some reporting. Data lake can be used for everyone. It can be used by data scientists, it can be used for data engineers. Everyone is using it. So this is data warehousing, right? When we talk about in this specific session, we will be talking a lot about data warehousing, something about data lake as well. But see, when we talk about data warehousing, we are talking about huge amount of data, right? One thing is very sure, we are talking about huge amount of data. It means when we are talking about huge amount of data and we are talking about traditional database, traditional data warehouse, we are talking about huge amount of money as well, right? This money will be spent on two things. The first thing is on the machines, right? The second thing is on the database or data warehouse experts, right? So machines will talk later, but what these data warehouse experts will be doing for you, they will define the strategy, how this data will be stored, how many partitions will be there, how many clustering will be there, how to performance tune some queries, uh, how to tune the software, how to tune some data warehousing concept. We will be covering them, but this is what this data warehousing expert will be doing. When we talk about machine, right? Machine means computing power. So what this computing or machines will be doing, whenever you write some query, let's say the same query what I was talking about, this query, right? That okay, Q2 2022, how many mobiles sell for Amazon in North America. When you write this query, you will obviously need some machine to process this data, which is stored onto some other machines, right? You will need some machines to compile this query and then run this query onto some other machines which have some data stored, get back the results, show it to user, right? So to run this query on large amount of data, you need very powerful machine, because you cannot wait for 2-3 hours or 2-3 days to get the result out of the query, right? And this is where these machines are very powerful in traditional databases, and these are very expensive. So now we got to know that okay, traditional data warehouse are also doing the same thing. What obviously Snowflake will be doing, but Snowflake will be doing this in different way. Okay, let's see how it is doing. So the first thing, obviously, what we covered in the definition of Snowflake is software as a service, right? And when we talk about software is nothing but your data warehouse. So Snowflake is data warehouse as a service. This thing is clear, right? Now, since this service is provided on cloud, so the question arises, which cloud Snowflake can run on? So the answer is Snowflake supports all the major cloud vendors, Google Cloud, AWS, and Azure. Okay. So when we talk about Azure, it will be storing data into your blob storage in some containers, right? Uh, in Azure. When we talk about AWS, it will be storing in S3 in some buckets, correct? And when we talk about GCP, it will be storing into GCP concepts, correct? So the what I want to prove you here that Snowflake will adapt according to the preferred cloud, and we as a customer has power to choose our own cloud. Like we can choose GCP, AWS, and Azure, right? So Snowflake is majorly providing data warehousing services, but on the top of that, Snowflake is providing a lot of other services. So obviously the major service which Snowflake is providing data warehousing, but Snowflake can be used for data engineering, data lake, data science, data application, and data exchange. We will be covering them all of them in a lot of detail, but what we can say that Snowflake is not just a data warehouse, it is providing a lot of other services which are needed for any data application. Now, when we talk about any data services, we need two things, source and sink, right? So when we talk about sources, in sources, we can have OLTP databases that are nothing but our normal RDBMS databases. We can have enterprise application, we can have weblog, IoT. When we when we talk about consumers or sink, right? We can have different type of reporting tools. We can have ad hoc analysis, real-time analytics, data monetization. This is a very interesting concept. We will be covering it. Like if you have some interesting data and if you want to share it with outside world, you can ask some money as a subscription fee for your data, and Snowflake supports that as well. Okay, we will be covering it, but see, Snowflake covers a lot of services out of the box, and we will be covering it. Okay, um, when we talk about any data analytical application, there are four things which are needed: loading the data, integrating it with different other data sources, analyzing it, and then collaborating between different teams who wants to use the data, correct? What Snowflake is doing, Snowflake is providing a single platform in which you can load, integrate, analyze, and collaborate using that. Okay, and the same thing is explained here in different way. So we can have different data sources: OLTP, enterprise application, weblog, IoT. We can do either ETL or ELT, and then we can dump the data either in EDW, it means your data warehouse, or into your data lake, right? So in EDW, when we are dumping the data needs to be structured or semi-structured at the max. In data lake, the data can be anything. So from weblog and IoT, the data is coming into semi-structured or unstructured format. So we are dumping in data lake. In Snowflake, from these data sources, the data is coming into structured format or semi-structured format. We are dumping in EDW, right? From EDW or from data lake, either we can do some analytics. So Snowflake has different integration with different analytics tool. We can cover it later, but what I'm showing here that we can have the integration of Snowflake, EDW, or from data lake or through data marts as well. So data marts are nothing but a single uh, subject oriented data warehouse. Okay, so small data warehouse you can say. So we have covered it that Snowflake is one platform, one copy of data, and many workloads. So basically, these different things, data engineering, data lake, data warehouse, data science, we can call them a workload, and they can use one copy of their data uh, to do some analysis over that, right? Um, okay. Now the most important thing, Snowflake is based out of cloud, right? So all the services what are applicable or all the benefits what are applicable to the cloud are applicable to Snowflake as well. The first major benefit of cloud is elasticity, correct? And when we talk about elasticity, elasticity can be of three types. The first type is storage. It means, let's say if right now we need 1 TB of data to be stored, let's say next month we have 2 TB of data requirement. So what Snowflake, since Snowflake is hosted on cloud, We just need to add some machines, virtual machines, or some containers, right? Virtual machine for computing, and containers or buckets for storage, and we are ready to go, right? So elasticity can be easily achieved because we are hosted on cloud. So elasticity, scaling, elastic storage, and concurrency. So let's cover one by one. So elastic scaling for storage is a low cost cloud storage, fully replicated and resilient. The same thing which is applicable for your Azure blobs, or S3 for AWS, right? When we talk about elastic scaling for compute, it's virtual warehouses scale up and down on the fly to support workload needed. We will be covering virtual warehouses in a lot of detail, but let me cover for 2 minutes. So virtual warehouse is a cluster of computing machine, right? Which will perform all the analysis for you. So virtual warehouse, um, so when you need more power to process the data, you will have more virtual warehouses. And virtual warehouse has the capability to go like to scale vertically and horizontally. So you can add more machine to the cluster, or you can increase the power of each machine of the cluster, right? When we talk about concurrency, so scale concurrency using independent virtual warehouse. So in single virtual warehouse, so let's say we have 5 different use cases. One is for your team one, who want to perform some data for your, let's say, data science. One is for reporting, one is for development, one for marketing. Now these different teams can have different need for computing. For example, for testing team, we might not need a full-fledged or a very high-end machines to process the data. They can wait, right? So they can have their own virtual warehouse with low computing power. When we talk about reporting, obviously reporting is the most important thing, because that's why we are doing all this stuff. They can have their own virtual warehouse with more machines and more powerful machines. what what I'm trying to prove here, that scale concurrency using independent virtual warehouse. So every team can have multiple different virtual warehouses to process the data. Okay. So and virtual warehouse can be horizontally scaled, or sorry, vertically scaled or horizontally scaled. And the same concept which we learned in cloud are applicable here as well. Okay. Um, okay. Now, when we talk about data warehouse as a service, what exactly Snowflake is doing? Snowflake is obviously providing us infrastructure, what we have covered. In that infrastructure, we have three things, right? Storage plus computing plus concurrency. So this is all about your infra, correct? Now, but data warehouse is just not only about infrastructure. It is more about your data warehousing expertise, right? I told you what database, data warehousing, why data warehouse are expensive, right? So this is the major cost of it. So what data warehouse expert or database admins are doing for us, they are doing a lot of things for us: query optimization, index management, data partitioning, metadata updates, data protection. So what Snowflake is, guys, obviously we are taking care of infra, but we are also taking care of all the data warehouse related activities. So you will get data warehouse out of the box, and you as a customer only need to worry about data analysis and data modeling. Obviously, we Snowflake says we cannot define table for you guys because we don't know what you want. So you need to do these two steps only. Or rest all the stuff, hardware infrastructure, software infrastructure, and data warehousing services will provide for you. Now, since data warehousing services are provided by Snowflake, hardware services are provided for Snowflake, and hardware and software services. So what Snowflake is, you need to know nothing about infrastructure or knobs or tuning. We will take care of everything. So we'll take care of infrastructure management, data storage management, metadata management, and manual query optimization. We will do it for you. Like we will do in our own way. You do not need to worry about it. So there is no infrastructure knob or tuning required from your side. And since um, there's nothing required from your side. It's a zero management data warehouse for you. We will you just need to load the data and we will do the rest. Zero infrastructure and admin costs, secure and highly available data, fully management with no knobs and tuning required, no indexes, distribution keys, partitioning, or vacuum required. We will take care of all this part. Okay, Snowflake is providing all these services for us. Okay, now I covered it in like 5 minutes back, but Snowflake stores all your data. Doesn't matter whether its data is structured, semi-structured, it will have the capability of ADW, that means enterprise data warehouse plus data lake. So in all, it will store all type of data from web, IoT, enterprise, corporate, mobile, and third-party apps, right? Um, Obviously, and Snowflake is a single platform for all of your users. They can have their own warehouse, and warehouse is nothing but a cluster of compute machines. Okay. Um, this is important. So basically, what these Snowflake guys did some research, market research with different companies. For example, when they did the research for telecom company, they said improved performance while adding new workloads at a fraction of the cost. So what these guys were talking about, that one telecom company was spending 5 million to expand their infrastructure of data warehouse appliances, but when they went to Snowflake, they just need to spend only 50K. So it means Snowflake is cheaper when we compare it to on-prem data warehouses. Okay. Uh, okay. Now this thing is important as well. So when we talk about cloud, majorly all the services in cloud are pay as you go. And since Snowflake is cloud agnostic and 100% cloud technology, Snowflake also supports the same thing, pay as you go. So when we talk about pay as you go for Snowflake, and when we compare it to traditional warehouses, in traditional warehouses, it doesn't matter how you are using your services, how you are using your Snowflake data warehouse, the cost will be at the same. Like it will be constant, right? Because obviously you have already bought those machines. When we talk about Snowflake, since we are using cloud services, so cost will go as you go. See this line, right? And that's where the on-prem data warehouses, we need $10,000 to support 1 TB of the data per year, and for Snowflake it's only $360 per TB. Okay. Now Snowflake, and that was I was talking about earlier, right? So Snowflake has the integration with different tools in business intelligence, data integration, ML, and security and governance. Some tools support Snowflake out of the box. Some tools need some configuration. But with all the major tools, Snowflake has integration. I will be showing integration with one of the tool called Power BI, but we can have integration with majorly all of the tools, right? Um, Okay, so this is all about Snowflake introduction, correct? Now, let's go to Snowflake website and see how to sign up and how it looks like, okay? So let's go to Google and let me start from beginning, snowflake.com. So when you go to snowflake.com, here's the button where it will say start for free, okay? So when we say start for free, it will open a page for you. You will enter some thing here, let's say anything, your Hadoop tutor at gmail.com, company, let's say test, and Ireland, and continue. This thing I was, I wanted to show you guys. So Snowflake has different editions, which we will be covering in 2 minutes. But this is the most important thing. Choose your cloud provider. You as a customer has the power to choose your cloud provider, where you want to store the data, which computing framework you want to use. For example, in Azure, it's virtual machines and blobs, right? In AWS, it's S3 and EC2. So let's say we want to go for Azure. Then let's say I'm an island. I want to go for Europe, island region. So it should be somewhere here, North Europe, island, and then I'll say get started. You will get some email, and then you can open Snowflake with your login password, and it will open something like this for you. I'll be covering it later, but let's cover two things. The first is addition, right? So we have seen there three additions: standard, enterprise, and business critical. But in Snowflake, in real there are four additions. The fourth addition is called virtual private Snowflake. So we will be covering it. Let's see how different additions differ from each other and which addition you need to choose. To practice Snowflake, obviously we will go for standard edition, because standard editions are cheaper, right? They're cheapest amongst all the edition. So what standard edition do for you? It's a complete data warehousing solution for you. It has premier support. It has secure data sharing across regions. It has federated authentication, database replication, you know, external function, snow site, which we'll be covering, and we can create our own data exchanges. The only thing which standard uh, addition lags is time travel, right? So what time travel is? So let's say you created some table, you made some changes to the data, um, and you want to see your previous data, right? So what Snowflake supports? Snowflake says, guys, you do not need to worry again. We have the copy of your all the data which either has deleted or you have changed it, and we call that concept as time travel. We will be covering time travel in a lot of detail here, right? Here somewhere. But in standard edition, we can go till t minus one, transaction date minus one, right? Now in standard supports multi-cluster warehouses. So what multi-cluster warehouses in reality is? So let's say when customer loads increases, for let's say you have some storage here, right? And let's say five people are connecting it, and they are getting results in optimal timing. Let's say during peak time, five more people connected. So what exactly happening here? That there will be a bottleneck, right? So when these five people connected to your data warehouse, there will be a bottleneck here. So what Snowflake says, if you are an enterprise edition, and obviously if you have done some setting, what Snowflake will do? Snowflake will create a separate virtual warehouse for these guys, right? Virtual warehouse is what? It's just a computing cluster. So these people are connected using this virtual warehouse, and these five people will be connecting using different virtual warehouse, and we are calling it multi-cluster warehouse. One more important thing is enterprise. It can go till 90 days of time travel, right? It supports materialized view. It supports search optimization services. It supports dynamic masking, external data tokenization. We will be covering it most of the things, but it will support everything what standard has, and enterprise edition will support these additional things. When we talk about business critical um, Snowflake, so it will support everything till enterprise, right? But what business critical Snowflake edition says that, okay, guys, we are more compliant with different industry. For example, we are compliant with healthcare industry data with HIPAA support. We are compliant with payment industry data with PCI compliances, right? And we have tri-secret secure using computer managed key, customer managed key. So what consumer managed keys are? So Snowflake says that obviously we will be encrypting your data in standard and enterprise, but we will store the data using our own key. You don't have the control over the keys. But in business critical edition, what Snowflake says that if you want to use your own keys, we will support you. Okay. Then Snowflake business critical supports private link support, Azure private link support, right? Database failover and failback for business connectivity, and external function as well. Now, so obviously, most, if you want to have your data secure, if you want to follow different compliances, business critical is the application for you, edition for you. Now, if you want to have your data onto the separate machines, so what exactly Snowflake is that we are a cloud, we are using some cloud machines to deploy your Snowflake software, right? But if you want Snowflake to deploy or implement or install their Snowflake software onto dedicated machines which are just applicable or used by you, then you should go for virtual private Snowflake. in virtual private Snowflake, customer dedicated virtual servers are used wherever the encryption key is in memory and customer dedicated metastore will be there. Okay. So this is all about different editions. So when we go here in Snowflake trial, obviously we need to choose which edition we want to use, correct? Now let's talk about, obviously we talked about different features. Obviously, the less the features, the less the cost. Let's see how these different editions um, differs in cost. Okay, we won't be talking about VPS here, virtual private Snowflake, because that information is not publicly available. But when we talk about standard, enterprise, and business critical, this is the costing. Before we talk about costing, let's think about, or let's talk about how Snowflake charges money from you. Okay, so Snowflake charges to customer in something called credits. Okay, so what Snowflake, obviously, when we talk about Snowflake, we are talking about two things, right? The first thing is storage. We will be storing our data somewhere, right? The second thing is compute. We will be using virtual warehouse. And the third thing is data transfer. Data transfer, right? So what Snowflake says that, guys, we will be charging you for storage some particular fixed amount. We will be charging you for compute based on which virtual warehouse you are using. The It means on the size of the virtual warehouse and how much you are using that virtual warehouse, right? So, and the third thing, for data transfer, we won't be charging you. It means we won't be charging you directly. So what data transfer means what? Let's say if you have data in East Europe region, right? And you want to transfer it to West Europe, then obviously for Azure, let's talk about Azure. So for Azure charges $87 per 1 TB of data transfer. So what Snowflake says that we will be charging you the same amount what Azure charges to us. We won't want to earn anything from there. We will be charging you credits for your compute, and we will be charging you fixed price based on which addition, based on how much data you are storing. Okay, and all in all, Snowflake will charge the credits for virtual warehouses, how much you are using and which virtual warehouse, what type of virtual warehouse you are using, what machines are implemented behind the scenes. Okay, let's talk about the type of machines. So this is what we are talking about. Okay, in Snowflake, what this guy did to make it more relatable to people, they use the sizes of machines in the t-shirt style sizes. Start from extra small and go till 4x large. And extra small machines obviously is very small machine, and the more bigger the machine is, the more credit usage will be there. For example, for extra small, the credit usage per hour is 1, and if you go just one level up, the credit hour will be doubled. See, it is doubling when you're going one level up, right? And you can, if you ask me which machine I need to use, I say you need to hit and trial which machine is applicable for you. For practicing, I will be using extra small because I want to save my credit hour. So for trial purposes, Snowflake gives you $400 credit hours. Okay, so obviously if we want to use this Snowflake trial for more time, we can go for extra small, but uh, people can use small, medium, large based on their requirement. The only thing which I want to prove here is the credit hours. Okay, so the it depends which machine you are using behind your virtual warehouse. So virtual warehouse is made up of machines, and machines have some sizes. Sizes can go from extra small till 4x large, correct? So now go to the costing again. So costing comprises of three things: storage, computing, and data transfer. Data transfer is chargeback. Storage is, you know, per TB, what you want to charge. So let's talk about it. When we talk about standard edition, when we talk about standard edition, it will be charging us $2.60 per credit. It means if you are using extra small machines, which cost us 1 credit hour, right? 1 credit per hour, right? 1 credit per hour. See here, 1 credit uses per hour. You can use, if you are using standard edition, you can use this machine, which is extra small, 2.6 hours for $2.60 in simple terms, right? In enterprise, it will be, sorry, maybe I mistaken it, so forget about it. So it will be charging you 2.60 per credit. Okay, in enterprise it will be charging you 3.90. In business critical it will be charging you 5.20. So the more higher the addition is, the more price they're going to be charging you, irrelevant of the addition. They will be charging you storage. For example, for Azure, see here what I'm using Microsoft Azure, Northern Ireland, sorry, North Europe and USD, and they will be charging you $40 per TB. And if you commit for let's say for a year or so, they will be charging you $23. Obviously the same way cloud storage works for you, right? So this is all about addition and the charging model, how Snowflake charge back to you. um, so now let's jump to architecture. Okay, so we have covered introduction, we have covered additions, we have covered how Snowflake charges money from us, right? So Snowflake charges in credit hours. Credit are based on the type of machine and the type of addition what you're using, right? Now let's jump to architecture. So Snowflake is, to be honest, it's very fast. So obviously, uh, there must be some reasons why Snowflake is so popular and why it's so fast. So in Snowflake, we need to talk about Snowflake introduced a new architecture for data warehousing, and they call this architecture as multi-cluster shared data in the cloud architecture. So let's see what it is. Um, Before we talk about Snowflake architecture, let's talk about traditional data warehouse architecture. So traditional data warehouse are of usually of two types. The first architecture is shared disk architecture, in which you have shared storage and a single cluster. Shared storage, single cluster, right? And from this shared storage, different computing machines will be uh, reading data, right? So let's say if you want to increase the memory, there is a bottleneck here to increase the storage power, right? The other thing is, and here this uh, storage has been shared across different computing machines or clusters, right? Or machines. Uh, the other architecture is share nothing. So it means, let's say you have 1 TB of data. So what this architecture says, divide this data uh, across different machines in such a way they are not sharing anything. So let's say you have 3 TB of data, right? So what this architecture says, store 1 TB here, 1 TB here, 1 TB here, and 1 TB here, so that they won't share anything. Okay, in this architecture, obviously, if these machines need this particular data, it won't be possible, and that's a bottleneck, right? So it's decentralized, local storage, single cluster. And obviously, when we see both the architectures, every architecture has some benefits. What this architecture has benefit, the computing is kind of uh, scalable, right? Here the storage is scalable. So what Snowflake says, why not mix the benefit of these two architectures and create something new? So what Snowflake says, we will create a multi-cluster shared data architecture. But when we talk about shared data, this shared data is scalable. So this won't be a single machine. This will be a cluster of machine where we will be storing the data. And on the top of that, when we talk about computing framework or computing, we can have multiple independent computing clusters. Okay, so these are computing clusters, and we can have as many computing clusters as we want. There is no limit on either on storage or on computing clusters. Okay, so this architecture is centralized, scale out storage, multiple independent computing cluster architecture, right? So this is obviously this architecture has benefit of both shared disk and shared nothing architecture, and it removes the bottleneck of both the traditional data warehousing architecture, right? Now coming to the architecture, obviously we know that Snowflake has a separate layer for computing clusters and separate layer for storage, but let's jump into one step deep. So when we see this data, right, and let's expand it a bit. So what Snowflake says that guys, we will have three layer architecture. The first layer is storage, and this storage is not a single storage. It will be shared storage, shared storage, which will be shared across different computing clusters, right? And this storage has the capability to scale horizontally as per the customer need. Then on the top of the database storage, we have a query processing layer, which will consist of multiple computing cluster. In Snowflake, we call them virtual warehouses. And we can have as many computing cluster as we want, depend on our need, right? And depend on the sizes. One more layer which I haven't talked about yet is called cloud services layer. So we know till now that we have data which is stored into some buckets, into some blob. We have virtual warehouses which will process the data. But what is the UI, and who will compile the data for you? Who will do the infrastructure management? Who will optimize the query? Who will do the metadata management? Who will do the security? So what Snowflake says, guys, we will create a new layer for you, and we will call that layer cloud services layer. And this layer, we can think as a brain of Snowflake. This will be muscles of Snowflake, right? Right? And this will be obviously storage. So brain will do all the computing or compilation. The muscles will do create the machine based on the needs, and then they will read the data from database storage, right? So this is three layer architecture what Snowflake provided us. Now let's jump further. When we talk about database storage, the data, when data is loaded into Snowflake recognize the data into internal optimized compressed columnar format, and Snowflake stores this optimized data in cloud storage, right? We talked about cloud storage. One thing which I want you to note here is compressed and columnar format. So when we talk about, when we store data, let's say we are loading some file names .csv, which is of 1 TB of size. So what Snowflake will do, Snowflake obviously will load this data into that cloud storage, but before loading it, it will do two things for us. It will store this data into columnar format, and it will compress the data. So it will do two things for us. So what's the benefit? We will cover it later, but Snowflake will be loading the data into columnar format and compressed format, right? Snowflake manages all the aspect of how data is stored. For example, it will, like for example, when we talk about organization, file size, compression, metadata, statistics about the file, everything is managed by Snowflake. Now, when we talk about query processing, query execution is performed in processing layer, right? Snowflake processes query using virtual warehouses. Each virtual warehouse is multi-processing, multiple parallel processing framework, compute cluster composed of multiple compute node allocated by Snowflake from the cloud provider. So it means it can be EC2, it can be virtual machines, or it can be Google related machines, right? Each virtual warehouse is an independent compute cluster that does not share compute impact on the performance of other virtual warehouses. This line is very important, and this is the crux of query processing. So what Snowflake says, that you have data storage here. You have query processing layer here. Let's say you have different use cases. The first use case is for data science team, right? The second use case is for data engineering team. These two teams can create their separate clusters, and these clusters, which we call warehouses, virtual warehouses, are independent of each other. They can read data, they can do anything, and they won't impact each other. So this is the very important thing. Let's say if one new use case came, you just need to create a new virtual warehouse, and it will automatically connect here and will read the data without impacting anyone. Now, the third thing is cloud services. The cloud services layer is a collection of services that coordinate activities across Snowflake. These services tie together all the different components of Snowflake in order to process user requests from login to query dispatch. So when we talk about Snowflake, we will have obviously have UI or some command line, right? So it will be UI, it will be command line. So whenever you are typing some query, you hit enter. So obviously we need someone who transfer this query which you typed to uh, query processing, let virtual warehouses. So which service is doing this for you? Cloud services, right? It will do on the very high level, it will do five things. It will authenticate you, you check your user ID password. It will do the infrastructure management for you. It will do the metadata management. It will parse the query and optimize it, and obviously it will do the access control. Okay. This is, to be honest, so this diagram will depict the whole conversation what I had for the architecture. So we have centralized storage, which will do the storage for you, and this storage will be based on the cloud services what you've chosen. For example, if you are chosen, if you choose Azure services, it will be uh, Blob, right? The cost will be around $40 per TB, correct? Uh, then the next layer is your computing layer, right? The computing layer will do different stuff for you, loading the data, ad hoc analysis, and development. And Snowflake will be charging you based on something called credit hours here, right? And the credit hours will be based on the which virtual warehouse you have used. Virtual warehouse will be dependent on which type of machines you have used, and the machines will go from extra small till 4x large, right? We have known this thing. The third thing is, the third layer is service layer, cloud service layer. The cloud service layer will do the optimization, management, transaction security, and metadata for you. And one more important thing, that for the cloud service also, Snowflake will charge you some credit hours. Okay. Um, Now the question arises: how much credit hours will be for your compute for your cloud service layer? On a So Snowflake has the upper limit. What Snowflake says, that for cloud service layer, they can charge maximum up to 10% of this. So let's say if your credit hour for compute is $100, they can only charge up to $10 for credit hours. Up to this, or maybe you know below some amount, this, right? Okay. So this is all about architectures. Okay. How this architecture makes the difference? Obviously, this will be performance oriented architecture, multi petabyte scale, up to 2x faster performance, and up to 1/10 of the cost. Okay. Concurrency, multiple groups access the data simultaneously with no performance degradation. Simplicity, fully managed by Snowflake, pay as you go model, works on any data. Okay. um, Secure by design, so it means obviously you will need user ID password. Okay, you can have multi-factor authentication, you can have federated authentication available. Now there are different access control layers. You can have role-based RBAC, what we call role-based access controls. You can have granular privileges. um, you can have data encryption. Data encryption can be managed by your keys or by Snowflake keys, and then you can have external validation. For example, PCI, DSS, HIPAA, SANS Institute, right? Different kind of stuff. So this conclude your architecture discussion. Before we jump to practical, let's talk about warehouses in other, like in one level deep detail, right? Um, so what actually a warehouse is? Warehouse, virtual warehouse, often referred to simply as warehouse, is a cluster of compute resources in Snowflake. The warehouse provided the required resources such as CPU, memory, temporary storage to perform the operation which are needed. For example, select DMLs, when you're updating, deleting, inserting a row, when you are loading data into Snowflake, when you are loading data out of Snowflake, right? Um, so that's where obviously what warehouse is a computing framework, right? Computing framework is your cluster of compute resources. Now, Snowflake says your warehouse size will be dependent on the size of machines which you have used to build that warehouse. And based on the size of the machine, Snowflake will charge you credits. Okay. So for example, for extra small, it will be 1 credit hour, 1 credit per hour, per second, it will be 0.0003, right? And this is the default size for when you create the warehouse. So if you're not specifying the size, it will be the default size, when you're using this create warehouse size. Um, when you are creating the warehouse by web interface, the default size is extra large. And extra large consumes 16 credits per hour. Um, 6x and 5x are only in preview feature, so they won't be available. So Snowflake utilizes per second billing with a 60-second minimum each time warehouse starts. So warehouse are built only for the credits they actually consume. In very, very simple terms, when you start a warehouse, minimum it will charge you for 1 minute, and then from 1 minute it will charge every second, right? So for extra small, it will be charging you 0.0003 after 1 second only, before after 1 minute only, before that 1 minute, after that 1 minute it will be charging 0.003 per second, correct? um, so okay, now the question arises, the $1,000,000 question: which size we need to choose when we go for data loading, which size of warehouse we need to choose when we go for data for query processing, right? For data loading, increase of the size of the warehouse does not always guarantee the query loading or data loading performance. The data loading performance is influenced by number of factors. For example, the size of each file, and then the size of the warehouse. So, for example, if you have very, very small files, it will take more time because obviously you need to maintain the metadata. So, if I ask you a simple question, if it is taking 1 hour for extra small to load the data, will it take 20 minutes for extra large machine? No, it's not guaranteed, because different types of factors will come here when we talk about data loading. Now, when we talk about query processing, this will make sense. For example, the query processing performance will improve as you go up, right? The size of the warehouse can impact the amount of time required to execute the queries submitted by the warehouse, particularly for larger, more complex queries. In general, query performance scales with the warehouse size because larger warehouses have more computing resources available for the processing queries, correct? Larger is not necessarily faster for small and basic queries, but for more complex queries, for larger queries, yeah, it will improve the performance. Okay. Before I cover here, let me touch one more concept called multi-cluster warehouse. I have touched that concept, right? So what multi-cluster warehouse is? It says by default size of the warehouse determines the compute resources available for the warehouse for executing queries. Each warehouse is a set of compute resources. As the query submitted to the warehouse allocate resources for each query and begins the execution of the queries, right? If sufficient resources are not available to all the queries submitted by the warehouse, Snowflake queues them, um, and additional queues all the additional queries until all the necessary resources become available. With multi-cluster warehouses, Snowflake supports auto allocation, or it will be either statically or dynamically additional warehouses to make a larger pool to compute resources. Now, don't worry about this big paragraph. What Snowflake says, if you are not using multi-cluster warehouse, and if the if all the resources of the warehouse are being consumed and there are more queries are coming, it will be added to some queue, right? These queries will be added to some queues and they will be processed whenever the resources become available. Obviously, this is the bottleneck of the performance, right? Now, what multi-cluster warehousing do? We can do a setting. We can do a setting that, okay, whenever there is a query performance bottleneck, please add more warehouses. We can do this warehousing adding either statically or dynamically, but whenever the load is higher, what it will do, it will add more cluster resources, so these queries won't be queued, it will be executed directly here, right? Maximum number of warehouses greater than 1 up to 10. Minimum number of warehouses, when we're talking about this multi warehouses, it will be uh, equal or less to the maximum, right? um, One more important thing which we need to talk about is, and the question is, how do we decide which warehouse size we need to use? Experiment with different types of the queries, different warehouse sizes to determine the combination of the best meet for your specific query needs and workload. So if you ask what is the best size for you, nobody knows the answer. You need to hit and try. No, don't focus too much on the warehouse size. Snowflake utilizes per second billing. You can run larger warehouses and simply suspend them when not in use. This line is very important. So basically what these guys are saying, it looks like extra small is the cheapest one, right? And 4x large, it may be expensive, right? So what, as a human tendency, it's like look like that we can use extra small, and we can use multiple extra small to process the query as in a cluster, and it will be cheaper than 4x large, but it's not always true. Maybe this thing will take you 1 hour, right? And with 4x large, the same query can be performed in 20 minutes. When you calculate it, it might comes out that 4x large for 20 minutes might charge you less than 15 extra small machines, right? So it doesn't always necessary that uh, warehouse size you need to choose small for the lower billing, right? Now this thing is important as well. The minimum billing charge for provisioning a warehouse is 1 minute. So what it means, that if a warehouse runs for 30 to 60 seconds, it will be billed minimum for 60 seconds. If a warehouse runs for 61 seconds, it will be billed only for 61 seconds. It means 60 seconds plus 1 second. If a warehouse runs for 61 seconds, shut down and restart, and runs for less than 60 seconds, it will be built for 121 seconds. How? So previously it go for 61 seconds, right? The next time it go for 60 seconds, less than 60 seconds. So basically what it did, when you start it for the first time, it will go for 60 seconds minimum, then this one extra, right? And then for the next time, might be you are using only for 1 second, but it will charge you for 60 seconds. So in total, in this case, it will charge you for 121 seconds. So what uh, we can show here, that there is no benefit of stopping a warehouse before the first 60 seconds, because the credit have already been built for that period. Okay. So this is all about warehousing. Now let's jump to UI first, and then we can go for data storage in 5-10 minutes. Okay, so when you log into your Snowflake, right? When you log into your Snowflake, let me log in here. So obviously you need to enter your password here. Let's save it. So the first thing which will come to you is the worksheet, which we'll be covering later. But the most important thing here, let it come here. 1 second. Tutors, sign in again. Okay, so let it come. So the first view will be of worksheet, but let's go to database and we will come to the worksheet later. So how many databases are into your Snowflake will be shown into the database tab here. So by default, Snowflake provides us 3 databases. In fact, 4 databases. Here, if I go here, and I'll show you the roles later, but let's go to account admin. So Snowflake provides us uh, 1, 2, 3, 4 databases. So this Snowflake database is very critical for Snowflake usage. So obviously, account admin has only access to it. Okay, and this database Snowflake sample data. You can use the data to practice Snowflake. And this demo and utility, obviously Snowflake provided for demo and utility database, right? Um, Now coming to the uh, share tab here. I was talking to you guys that okay, Snowflake data sharing is super easy, right? So what Snowflake says that you can share some like whatever data you have to different parties in the organization using your data share. Okay, the shares can be inbound and outbound, and you can create a new share as well. Okay, so what you can do, you can create a new share test, select the database. Let's say I want to select the new retail DB, select tables. Let's say I want to only go for public and I want to go for audit table, right? And then go here and then create it. And now once you create it, right, then you can test database create, and now you can add consumers here. So then you can have uh, whether you want to give them the full control or whatever control, reader control. You can have the reader accounts here, right? You can have full account detail here, and then you can add it, and they will be accessing this database easily. Okay, right now I don't want to do it, but this is how to do it. Now the most important thing is data monetization, which I promised that I will be covering it, right? So there's something called data marketplace in Snowflake. And when you go to data marketplace, what data marketplace is, let's open it. So what Snowflake says that guys, if you have some quality data with you, you can share this data to external parties and you can charge them money, right? And at the same time, you can also subscribe to some data sets which are available publicly. So let's say if you want to go here, let's go here, and it is free, right? We can request this data, and we can write whatever name we want to give here, then we can request data, and then they will share to us, and there will be new databases created for us. Same way we can create our own data sets, and either we can uh, present it for free, or we can have some uh, you know uh, money charged from the customers. For example, here should be some databases which should not be free. For example, let's go here. Oh yeah. So for example, this is personalized data. The cost is available on request, right? Uh, so there are data sets which might show you the cost as well. For example, let's say this one. This is free. So yeah, but I don't want to waste the time here. Let's see. One more thing is this one, commerce maybe. Yeah. So most of the data request when you do it, they will um, give you some quotation, and then obviously charge will be shared there, right? This is what called data monetization. Okay. Now, the thing what I was talking about for last 15-20 minutes about the warehouses. When you create the account, Snowflake will create one warehouse for you called compute warehouse. So this warehouse is created by Snowflake when you just create the account for, trial account, right? Now, when we click this, even before we clicking it, what we can see here that the status of this warehouse is suspended. The name obviously is compute warehouse. The size is extra small. How many queries are running? How many queries are, you know, queued? How many queries are running? Right now, these two things are very important, and I will be covering into presentation as well. Auto suspension and auto resumption. So what Snowflake says that you can give setting to your data warehouse. If you are not using it, if it is inactive for 10 minutes, we will automatically stop it, right? And what auto resume is, as soon as you log into your Snowflake, run some query, we will resume the database data warehouse if we needed some computing resources. It's not always necessary. If you run some query, it will resume the databases. What Snowflake do that once you start the data warehouse, you start running some query, it will have cache into it, like queries result will be cached. So every time if you run the same query, it might not need to go to the storage, it might not need to start this warehousing, it and there are multiple scenarios in which we don't even need the warehouse. um, Now when you are creating a data warehouse, okay, so obviously you need to give some test, let's say test. And here if you see, you can choose any machine, for example extra small. You can go for auto suspension. Let's say I only want to go for 5 minutes, right? And we can give some comment and we can say finish. And by default, it is started, but I don't want to use it. So I'll go here and I'll say I click just click here and I'll say suspend. Okay. So this is how you need to create the data warehouses. There are different ways to create it. This is the most easiest way. The most important thing where you guys will be working and developing things is called worksheets. So in worksheets, you will write any query, right? So here what you need to do, you need to say use whatever DB you want to use. Let's say I want to use retail DB, right? So first you need to create the DB, and let's say I want to use the retail DB. What I want to show you here, when I run this query, right? This query is executed successfully. If I go to my warehouses, every data warehouse is still suspended, right? So every time it don't need to use the warehouse. For example, let's say if I do describe orders, I have one table here, orders, and if I just say run it, so what's that? Describe table. One second, let's see. Maybe we need to put public here. Describe table. Yeah, so we need to describe table. When we go here in warehouse, it's still suspended, right? So it means all the commands might not be telling you to use or forcing the data warehouse to be started, right? So this is what worksheets are. When you go to worksheets, you can save them in whatever name you want to save. For example, this is my test or practice worksheet. That's simple, right? So once you go for practice, it will be saved. Now, whatever queries you have run so far, you can go to history. In a Snowflake, each query will have a query ID, and this query ID is very, very important because there are a lot of use cases which we can achieve through this query ID, which we will be covering maybe in part 2. But see, every query will have a query ID, right? Even all the failed queries will have query ID, and you can go here, you can see what that query was, right? How much time it took, which session it is, which warehouse it was using, correct? So this is what. One more thing is when you go here in worksheets, okay, you can select here which account, which role you want to run this query, which warehouse you want to use, obviously which database and schema which you want to use. Okay. Now when you go to accounts, in accounts you will have all the details, and this account is only visible for account admin role, and I will be covering the rows later, but this will show you how many warehouses that you have, how many credit you have used, what is the average storage used, right? One important thing which I want to show you here is this part. So obviously, Snowflake will be charging us credits for our data warehouses, and Snowpipe is something which I will be covering. This is serverless, which I don't want to cover now, but the thing which I want to cover is cloud services only. Snowflake will charge us credits based on how much we are using Snowflake, how much time we are using it, and this is again, you cannot control it, and it depends on how much time you are using the Snowflake, which machines you have configured so far, right? Um, Now, there is something which Snowflake is working on right now, and that's called Snowsite. It's a new UI what Snowflake is developing for us. It's in preview right now. So when you click it, it will open this for you, and you can see here it has a almost all the things what are there, but in a new way and more user friendly way. So for example, when you go for worksheet, right, you go to retail DB, it will see, it will tell you what you can say auto complete. So when it's orders, it will say orders, and even it is telling me 138k rows are there in orders, right? So I will be covering Snowsite as well, but Snowsite is very new feature. I really like it. I will be covering a lot of details here as well. Okay. Um, so um, this is what about Snowsite and UI. Okay, and now let's go to your second. Yeah, let's go to presentation again, and let's cover one more thing. Yeah, let's cover this thing. So obviously, see, Snowflake, we covered architecture, we covered uh, different layers of architecture, we covered additions, we covered what Snowflake is. But one more important thing is how Snowflake stores the data behind the scene, um, and how Snowflake queries are super fast. You know, so what Snowflake says that before we talk about Snowflake, let's talk about traditional data warehousing, how data warehouse experts were storing the data. So there's something called partitioning, right? Partitioning. So what partitioning is to partition the data based on some keys or based on some methods, and store the same partition for the same key in the same location, so that once you run some query, it will only go to that particular partition and the query can be faster, right? But but when these data warehousing experts were doing this partitioning, they need to define this partition before data has been loaded into the data warehouse, and that's what it is called static partitioning. There can be multiple ways to do it. For example, you can do hash partitioning, you can do range partitioning, but every type of partitioning you need to do before you load the data, right? And static partitioning might not be as efficient, you know. So let's read it. Traditional data warehouse relied on static partitioning of large table to achieve acceptable performance and enable better scaling. In this system, partitioning is a unit of management that is manipulated independently using a specified DDL and syntax. However, static partitioning has number of well-known limitations. For example, it needs the maintenance, it needs overhead, data skew can impact the performance. uh, in contrast, what Snowflakes do, Snowflake says, guys, you do not need to worry about partitioning because we are providing you data warehouse as a service. We will do the partitioning into our own way, and we will distribute, or we will partition your data um, into something called micro partitions. So we will do the partition and we will call each partition as micro partition, right? Now, what are micro partitions? All data in Snowflake is automatically divided into micro partitions, and these micro partitions can be of size of 50 MB till 500 MB, and this is the size of uncompressed data, right? So what Snowflake will do? Snowflake will uh, take the amount of data from 50 MB to 500 MB. It will compress it. It will create a micro partition out of it, and it will store it, right? Each micro partition contains between 50 MB to 500 MB of uncompressed data. Groups of rows in the table are mapped into individual micro partition organized in columnar fashion. Okay, so let's jump to one figure here. So let's say we have this data. Okay, so this data is there. Let's minimize it. Yeah, so let's say we have this data. This is obviously a logical structure of data. You have 4 columns: type, name, country, and date. And what Snowflake do? Snowflake is a column-oriented storage, right? So what Snowflake says, Snowflake will store each column together, right? It is not row-oriented, so it's column-oriented. So it will store this type column here, right? This is the type column, right? And this is the date column. So it will store the column together in more compressed way, right? This is column oriented. But what I want to cover here, that Snowflake will be storing data into micro partitions, right? So what Snowflake did here, that it divided this whole data, which is of 24 rows or 38 rows, let's say, I don't remember, but Snowflake first divides the data into a column oriented fashion. And then what it did, it take the data from top to bottom, let's say 6 rows in one partition, right? 6 rows in one partition, 2, 4, 3, 2, 3. So what it do, it just take one row at a time and store 2, 4, 3, 2, 3, 3, right? So it stored these rows here into here, and then it take name here, it's stored here in the name, it take the country till here and it's stored till here, and then it take the date and it store the date here, right? So this is how Snowflake stores the data. And obviously before, and this is just a logical uh, way of explaining it, might be different when it goes to practical implementation, but this is how the data will look like. Okay, so now once you query the data, it will only go to that particular partition. Okay, there are some limitation to it, we will be covering it in 2 minutes, but this is what partitioning is. So now let's go here. So Snowflake mapped the rows into partition, into column fashion. The size and structure allows extremely granular pruning of very large tables. Um, Snowflake stores metadata of all the stored rows in micro partition. So this is very important. So, and this is called metadata management. This is called metadata management, and this is the service provided by cloud service, the top layer, right? And in this metadata, what we have, the range of value of each column in micro partition. For example, it has max, min, and count. Max, min, and count of each micro partition, number of distinct value, additional property for both optimization and efficiency of queries. So let's say we have this micro partition called mp1. It will have some metadata stored to it. This metadata will be having data like max of every column, min of every column, distinct values of each column, right? So that whenever we run a select query, it won't need to go to directly to the partition. We will read the metadata first. If this data is available in metadata, then we will go to that micro partition. Now, what is the benefit of micro partition? The first benefit is it's very small in size, so which is extremely efficient for DML and fine grained pruning for faster queries, right? Micro partition can overlap with their range of values, which combined with their uniformly small size and prevent skew. Since micro size is very small, the skewness can be prevented. Columns are stored independently within micro partitions, often refers to as column storage. And since the best benefit of column storage is compression. So because let's say we have one column of string type, right? One column of date type, one column of number type. So we can give a compression technique which is relevant to string, which is relevant to date, and it will be more compressed and more easy to read, right? Columns are compressed individually within micro partitions, and automatically Snowflake automatically determines the most efficient compression algorithm based on the column in each partition, correct? Query pruning is nothing but to deselect or remove all the other partition which we don't need, right? So the micro partition metadata maintained by Snowflake enables precise pruning of columns in micro partition at query runtime, include column containing semi-structured data as well, right? Um, One more important concept is called data clustering. So micro partition obviously is a very good concept which will do all the partitioning for you, store the rows, maintain the metadata, helps in query pruning. What one limitation we can say of micro partition is that when you see here, right? Let's maximize it again. That micro partition will store data from top to bottom. It will take these rows stored in MP1, micro partition 1, take these rows stored in MP2. Can we make sure that when we run some query for date of 11/2, it will only go for MP1? No, right? Because 11/2 date can come anywhere here as well. And now this row will go to this partition, obviously, right? Because we are going from top to bottom. So this is one limitation, what we can say of micro partition, and that's where we once, if data is sorted, obviously this problem won't be there. But if data is not sorted, like for example in this case, this problem can be there. And if your table is super large, for example it's 1 TB, then obviously you need to go to multiple micro partition to read the data, and obviously this is the limitation. So what Snowflake says, that guys, if you have table greater than 1 TB, what you can do, you can define the clustering key. You can define the clustering key, and based on that clustering key, we will first sort the data, and then we will store that data into micro partition, right? Now, what's the benefit? So let's say we are running this kind of query. Select name country from table 1, where type is equal to 2 and date is equal to 11/2. So in this case, if we cluster by type and date, it means in most of the cases, right? For example, before clustering, what it was doing, see, 11/2 is going to 3 different partition, right? Here is 11/2, 11/2, 11/2. Even type 2 can be of, in multiple micro partition. If we do the clustering by date and type, right? So what this guy did for us, first of all, it tried to move all the type 2 to one partition. At the same time, it tried to move all the 11/2 into one partition. So now into this case, when we hit this thing, when we run this query, it will go to this partition 11/2 here, 11/2 here, 11/2 here, and then it will go to 2, 2, 2 here. It needs to go for three things, three micro partition to get the data. When we do the clustering, it only need to go for 2 micro partition, right? So if we read it, the table consists of 24 rows stored across 4 micro partition. The rows divided equally in each micro partition. Within each micro partition, data is stored and sorted by column, which enables Snowflake to perform the following action. First, prune the micro partition that are not needed for the query. Then prune the column that are not within the micro partition, remaining micro partition, right? Clustering information maintained for the micropartition. So Snowflake maintains the clustering metadata for micropartition in the table, including the total number of micropartition. The total number of micropartition contain the value overlap for each other. Now, one more concept is called overlapping and clustering depth. Okay, so before we jump there, let's see this thing. So let's say you are storing data from A to Z, only alphabets, right? And you have 5 micro partition for it, 5 micro partitions for it. So there are different studies of micro partitions, right? So let's say if you have 5 micro partitions, and each micro partition can have data like, let's say this micro partition can have B, C, D, and Z. This micro partition can have A, X, Y. This micro partition can have M, N, and let's say D or A, whatever, right? So what we can see here, that if we want to write a query like select data from where alphabet is into A to Z, not Z, let's say from X till Z. In this case, it needs to go through multiple micro partition. What we can see here, that the overlapping for all this micro partition is 5. It means all the 5 micro partition needs to be queried when we run some query, correct? Because there is no distribution, or we don't know where data for our query lies here. We might need to go for all the partition. And this way, what we can say, the overlapping is 5, and overlapping and query depth or overlapping depth is interrelated. In this case, we will have 5 as overlap depth, right? Now coming to this, let's say we have again 5 micro partition, but now we store data like this. From A to D, we are storing in first micro partition. E to G, we are storing here. From K to Z, we are storing in these 3 micro partition. What is the overlapping here? 3. So the depth is 3. Now coming to the best case, let's say we are storing A to D here, E to J here, K to N, and then so on. In this case, there's no overlapping. Each micro partition has separate set of data. In this case, the minimum overlapping is 1. Okay, so what we can say here, before even before we jump further, right? The lower the overlapping is, the better the query will perform, right? Sorry, the lower the overlapping depth is, the lower the overlapping is, the query will perform better. Okay, so this is what called overlapping. Let's go to the definition, bookish definition. Okay, clustering depth. Clustering depth for a populated table measures the average depth of the overlapping micropartition specified column in the table. The smaller the average depth, the better clustered the tables is with regards to the specified column. Clustering depth can be used by a variety of purposes. For example, monitoring the clustering health for large table, determining whether the large table would benefit from explicitly defining the clustering key. The table with no micro partition has the clustering depth of 0, obviously. Um, we, let's say we create one clustering key, right, on X column. Can we make sure on the long run there will be no skewness or there will be no overlapping? No, right? Because obviously we don't know what the data will coming in future. So we might need to check the clustering depth throughout the time to see the health of the data, right? Clustering depth for a table is not an absolute and precise measure of whether a table is well clustered. Ultimately, query performance is the best indicator how well your cluster table is, right? If queries on the table are performing as needed and expected, the table is well likely clustered. If queries performance degrade over the time, the table is likely no longer well clustered and may benefit from clustering. Okay. Um, so this is all about clustering and micro partitioning. This is again a very good example. Let's say we have table like this. Okay, so in tables we have 2 columns. Before reclustering or before clustering, we have in micro partition 1 till here, we have column 1, 3, 5 and 6, 1, 3, 5 and 6, and column 2, 1, 5, 9 and 12, right? So when we go to micro partitioning 1, we have 1, 3, 5, 6, 1, 5, 9, 12. In micro partition 2, the same thing. So now when we recluster the table, based on C1 and C2, we know when we are clustering the table, it will be sorting the key. So it means it will sort the table and it will obviously store 1, 2, 3, 4 column values of each column together. So now this is our data looks like when we have no sorting done here. And this is our data looks like when we've sorting done. So 1, 1, 2, 2 will come to the micro partition 1. 1, 2, 3, 4 will come to the micro partition 1. See? 1 1 2 2 and 1 1 1 2 3 4, and now when we run the query, obviously it will go to the micro partition 1 if the c1 is between 1 and 2 and c2 is between 1 and 4, right? Okay, so this is again a very good thing, and again I'm maybe repeating the same concepts in micro partitioning. Micro partitioning 1 column 1, and this is the metadata looks like. Okay, before, what is the minimum value? 1, maximum value was 6. In And after clustering, minimum is 1, maximum is 2. For C2, it was 1 and 12, and after the clustering, it was 1 and 4. So what is the benefit now? Let's say before we were writing the query like select star from T1, where C1 equal to, let's say, 5. In this case, where it will be going? It will go here, it will go here, it will go here, it will go here, and then it will go here. In this case, this particular case, after reclustering, it will only go here and here. So 1 2 3 4 5 and 1 2. So Before reclustering, it will hit 5 micro partitioning. After reclustering, it will only hit 2 micro partitioning, and that's the benefit, performance on the performance, right? This is all about micro partitioning. We will be covering a lot of details, how to do it, when to do it, all the syntaxes in next lecture. So this is the part one of the Snowflake. The next session will be fully practical, in which we will be covering about time travel. We will be covering about uh, snowpipe, search optimization, views, variables, file formats, import and export, and then different roles. Okay. uh, Again, thanks for the time, guys. Really appreciate, and please do subscribe the channel. That's the only motivation which I have. Do comment, like the video if you like the content. Thanks a lot again for the time. Really appreciate.